So we're already in week 5. We're getting ready for test 2 now. You have a couple of quizzes due this week. Make sure that you complete them by the required due date. So last week we were talking about multiplying with polynomials, and we want to continue with that by squaring a couple of binomials. Now this is very different than squaring a monomial. Do you remember we talked about that earlier? We said if we had something like 3a cubed to the power of 2, the power of a product rule said that we would square everything inside the bracket. And this would give us 9a to the power of 4. That's not what we're looking at here. We no longer have the power of a product. This is a power of a sum. We have that plus sign inside the brackets. So whenever you have more than one term inside the bracket, we need to be very careful. So we're squaring a binomial. We said when we were talking about powers and exponents that that exponent squared everything it was beside. It's beside a bracket. So we have 5x plus 9 times 5x plus 9. We could have done the same thing in my example up top here. Let's erase this. I could have said that this was 3a cubed times 3a cubed. Well, that's just 3 times 3, and a cubed times a cubed, add the exponents. So you're going to get the same answer. Here, 5x plus 9 times 5x plus 9, remember that each term in the first bracket, 5x, has to multiply the second bracket, plus 9. When we open the brackets, using the distributive property, we see we have like terms in the middle. This gives us 25x squared plus 90x plus 81. It does not give us 25x squared plus 81. There's that middle term that often gets forgotten if people aren't careful here. Why don't you pause the video and try squaring the next binomial? (2x times the second bracket, -7 times the second bracket. Use the distributive property twice, and then combine like terms. Now, some of you probably have a formula for squaring binomials. If you know that formula, you are welcome to use it. If you don't know the formula, I'm not going to ask you to memorize that one in particular. I think it's pretty easy to simply multiply out the squaring the way we've been doing it here. And besides, you probably need the practice multiplying binomials. If you haven't finished the last one, pause your video and do so. I hope you were a little bit surprised by this final product. In most of the binomial multiplication we've been doing, our final answer has either been a trinomial or a polynomial of 4 terms. And in fact, here we had a trinomial, here we had a trinomial, but in this one, our answer is a binomial. This is a special case in the world of multiplying binomials. Pause your video and finish this last one if you haven't already done so. And here again, our product was a binomial. Take a look at the 2 questions we have here. Why do you think these 2 products gave us an answer that is a binomial when these 2 gave us products that were a trinomial? 5x plus 9 squared was 5x plus 9 times itself. 2x minus 7 squared is 2x minus 7 times itself. These 2 binomials are almost the same, but not quite. We have a plus 8 and then a minus 8. We have a plus 11 and then a minus 11. These last 2 products were a binomial because the middle terms were canceled. This is known as a difference of squares. Let's go back a minute and look at those 2 binomials. A difference of squares. Well, a difference because we're subtracting one. A difference of squares. 4x squared could be written as 2x all squared. 64 could be written as 8. Here, a difference of squares, we have x squared minus 11 squared. Now, I'm not trying to confuse you. Our final answer is this binomial. But I want you to see that that binomial could be written as a difference of squares, the subtraction of squares. Every time we multiply binomials, a plus b times a minus b, where the first terms are the same, the last terms are the same, and then we have a plus sign and a minus sign, the product will be a squared minus b squared. And in fact, I'm going to suggest to you that we use brackets, a squared minus b squared. That's just to prevent some common mistakes we see happening. Let's multiply these using that formula. You see we have a plus b times a minus b. We see that a is 2x and b is 8. So using the formula, we know that our product will be a squared minus b squared. You need to open those brackets. Our product is 4x squared minus 64. Pause your video and do the next one. we see that A is 3x and B is 1. A squared minus B squared, or 9x squared minus 1. You're going to have to really pay attention so you don't miss these difference of squares when the questions are asked. You can get the right answer by doing all of the work, right? We did that here. We did just our usual binomial multiplication, first term times the second bracket, last term times the second bracket. You're still going to get a correct answer, but you need to teach yourself to see this difference of squares. That's going to be really important to us as we move ahead. Did I misspell binomial? I did. There we go. All right, we want to go back and talk about exponents a little bit. Think about this question. 2 to the power of 4 divided by 2 to the power of 7. If I use expanded multiplication, it looks like this. And when I divide, 2 divided by 2 is 1. I have 1 over 2 cubed. Now, if you were thinking about that quotient rule we talked about last week, we know that this would have been a to the power of m minus n. That means that this would have been 2 to the power of 4 minus 7, or 2 to the power of negative 3. 2 to the power of negative 3 then is equal to 1 over 2 to the power of 3. Those negative exponents do not mean you're going to have a negative answer. That negative exponent, I like to just think of it as a little f, tells me to flip this over. I had 2 cubed over 1. It's going to become 1 over 2 cubed. So we say if n is an integer greater than 0 and our base, a, is a real number, if we have a to the power of negative n, it equals 1 over a to the power of positive n. So let's try using that. 3 to the power of negative 3 can be written as 1 over 3 to the power of positive 3, or 1 over 27. 3 times 3 is 9, times 3 is 27. Be careful on this second one. We've said that the exponent applies to what it's directly beside. What's the exponent on 2? A positive 1. So 2 stays, but that x to the power of 4 moves to the denominator. When I flip it down to the bottom, it becomes positive. Same thing here. It's next to the brackets. So now I have 1 over negative 2 in brackets with a positive 4. This equals 1 over positive 16. Now it's next to the 2. What's staying in the numerator is that negative 1. This one equals negative 1 over 16. Be careful with those negative signs. Be careful with those negative exponents. All right, what about this question? 1 over 2 to the power of negative 4. Well, I'm going to write that 1 over. Now let's change colors here for a moment. We said that 2 to the power of -4 can be written as 1 over 2 to the power of +4. So I've just rewritten this part with a positive exponent. Now we have a division question. Let's write it horizontally. 1 divided by 1 over 2 to the power of 4. Remember, when we're dividing with fractions, we multiply by the reciprocal. We can see by this example that if you have a negative exponent in the denominator, by flipping it to the numerator, the exponent became positive. Again, that negative exponent is just saying flip it over, make the exponent positive. And so we say, if n is an integer greater than 0 and a, the base, is a real number, if we have 1 over a to the power of -n, we can write this as a to the power of +n. What you're going to find in my math lab and in your e-text is that you're always going to be asked to write your answers using positive exponents. I suggest making your exponents positive first. That doesn't have to happen all of the time, but I find it's generally easier for people to work with positive exponents. So in our first example, 4 to the power of -2, we just need to flip that over. And then we have a +2 in the denominator. This equals 1 over 16. The second example, x to the power of 4 over x to the power of 7, could be thought of in two ways. Let me show you both. First of all, you could use that dividing powers with the same base rule. We could say that this is x to the power of 4 minus 7, which is x to the power of -3. In order to make it positive, I need to flip that to the denominator, and 3 becomes positive. Or you could just look at this question and see that there are more x's in the denominator. There are 3 more x's in the denominator, so I know that I'm going to have 1 over x cubed. Let's look at the next example. 2 to the power of -3 over 2 to the power of 5. I'm suggesting we make our exponents positive. So 2 to the power of 5 is already a positive exponent. It's going to stay in the denominator. I want this 3 to be positive, so I'm going to move it. That leaves 1 in the numerator. Now, I'm multiplying powers of the same base in the denominator. Keep the base, add the exponents. Powers of 2 are pretty easy to evaluate. Remember, I suggested you memorize 2 to the power of 5 is 32, 6 is 64, 7, 128, 8, 256. All right, these are both negative exponents. So 5 cubed, flip it to the bottom, 5 to the 1, move it to the top. Now, where are most of the 5s? They're in the denominator. How many? 2 more. Or I could have said that this is 5 to the power of -2, which of course equals 1 over 5 squared, or 1 over 25. Why don't you pause your video and try the next two? I have 3 squared, it's positive already. I want this one to be positive, so I'm going to move it to the numerator. That leaves 1 in the denominator. I can ignore that. Multiplying powers with the same base, add the exponents. Did you get 81 there? All right, they're both negative. So we'll have negative 3 to the power of positive 4 over negative 3 to the power of positive 2. Most of the negative 3's are in the numerator. 4 minus 2, this is negative 3 squared, or 9. Let's do some more practice with positive and negative exponents. I'll do the first two with you, and then I think you should pause the video and give it a try. Again, I think it's easiest if we make our exponents positive first. M cubed is already positive. Make this one positive. Make this one positive. That leaves 1 in the denominator. Multiplying powers with the same base, add the exponents. Making them all positive. X to the power of 4 is already a positive exponent. I'll flip these down. That leaves 1 in the numerator. Keep the base, add the exponents. All right, pause your video. Maybe after you do one, turn it back on, check your answer, pause again, and keep working. So 2 has a positive exponent. Let's make this one positive. 2 squared. Let's make this one positive. Let's make this one positive. I would simplify the numerator, simplify the denominator, keep the base, and add the exponents. I see that most of the 2's are in the denominator. 4 more in the denominator. All right, this one's a little bit different. We can apply that power of a product rule. Everything inside the bracket is raised to the power of negative 3. So now we have negative 2, move it to the denominator and make it positive. X, move it to the denominator, make it positive. Raising a power to a power, we multiply our exponents. It's y to the power of positive 9. It can stay in the numerator. I can open the brackets for negative 2 cubed. So we have y to the power of 9 all over negative 8x cubed. I don't know why my 3 is being funny. That negative sign, we don't want it in the denominator. We want it either outside the entire fraction or in the numerator. All right, everything inside is raised to the power of negative 1. X to the power of negative 1, move it to the denominator. Negative 1 times negative 1 is positive 1. So we have negative 2 raised to the power of negative 3. X raised to the power of -3. Y -3 raised to the power of -3 all over x to the -1 over y to the +1. Can we clean this up? Well, I want that to have a positive exponent, -2 to the power of +3. I want this to have a positive exponent. Move it to the denominator. -3 times -3 is already positive. Make this a positive exponent, move it to the numerator. This one already has a positive exponent. Leave it in the denominator. Now I have positive exponents on all of my variables. But can we clean it up a little bit? Sure we can. First of all, we have that -2 cubed. We know that's -8. Let's put the negative outside. I see x's in the numerator and the denominator. There's more x's in the denominator. How many more? 2. I see y in the numerator and the denominator. There are more y's in the numerator. How many more? 8. Give this last one a try if you haven't already done so. So we're first going to use that power of a product rule and apply the power of -2 to everything in the numerator. And then the power of -3 to everything in the denominator. You don't necessarily need to write that step out. Let's use another colored pen so you can see maybe more easily what I'm doing here. All right. We have a negative exponent here. Let's make it positive. -3 to the power of +2. Here, this is positive. This is going to be y to the power of -4. Let's move it to the denominator. Let's make this exponent positive. That gives me a -2. I'm going to put it up here to the power of +3. -3 times -3, that's a +9. -1 times -3, +3. So what have we got here? -2 cubed is -8. We're going to put that negative outside. -3 squared, that's +9. I have x in the numerator and x in the denominator. There are more x's in the denominator. One more x in the denominator. My y's are all in the denominator. Keep the base, add the exponents. These are tricky questions and they take a lot of practice. So please spend the time you need in my math lab, in the homework, and in your e-text practicing these questions. I believe there are also some extra worksheets for these posted on your class Moodle page. The last thing I want to talk about in this lecture is dividing polynomials by a monomial. A monomial, remember, has no adding and subtracting in it. So we're just dividing a polynomial by a monomial. And if you think back to our fraction lesson, we said if you had a over c plus b over c, then you could just write a plus b over c. This is very important. This idea reminds us that that denominator belongs to every term in the numerator. Because if you look at my first example here, what a lot of people want to do is say, oh, look, 6x divided by 6x. No, if you do that, I am going to come through your computer and take your pencil away. Absolutely not. If you do that, then I know you haven't watched this video and listened to everything I'm saying. I just said that that denominator belongs to each term in the numerator. So we have negative 12x cubed over 6x minus 24x squared over 6x plus 6x over 6x. Now you just need to simplify each of these. Negative 12 divided by 6 is negative 2. Subtract the exponents. Negative 24 divided by 6 is negative 4. Subtract the exponents. I don't need to write that one. 6 divided by 6 is 1. Subtract the exponents. But x to the power of 0 is, of course, 1. This is your answer. Let's look at the next one. Every term in the numerator is written over the denominator. And so we can simplify this. Negative 9 divided by 3, subtract the exponents. 3 divided by 3, subtract the exponents. I don't need those ones. We can just say that this is x. Negative 12 divided by 3. There's no x's on that 12. But remember, we could think of this as x to the power of 0, which means when we're subtracting the exponents, 0 minus 3 is negative 3. But of course, we like our answers written with a positive exponent. That means I can take this and write it as negative 4 over x cubed. Pause your video and see if you can do the next two. So you can look at that first term, and there's nothing I can do with 4 divided by 7 except get a decimal. We're going to leave it as 4 over 7. There's more a's in the numerator. Same thing with 12 over 7. Nothing I can do but leave it as an improper fraction. 7a squared divided by 7a squared equals 1. You need that 1 there. Four x squared divided by 4x squared is 1. Minus 4x to the power of 5 plus 5x cubed. We'll stop there for today. Make sure you get your quizzes started. There'll be more later.